Hi friends, welcome to Mechanical Explorations. Now in this video we are going to see about the basics of thermal engineering continuation, that is followed by the two parts. Now first coming to the conversion of temperature. How can you convert the temperature? That is in degree Fahrenheit and temperature in Kelvin. The formula C by 5 equal to F minus 32 by 9 also equal to T minus 273.15 divided by 5 is to be remembered for the conversion of temperature. And it also specified it's a point where all three phases coexist. It is known as triple point of water. Now methods of temperature measurement, the two methods used before 1954 is T equal to 100 P minus Pi divided by Ps minus Pi. Here Pi stands for pressure corresponding of ice point and Ps stands for pressure corresponding of steam point. After 1955, it is termed to be T equal to 273.16 where P by PTP, in which PTP is defined as property corresponding to triple point of water, in which it said as all phase coexist. Now coming to what is ideal gas equation. Any gas that behaves ideal, that is concept under low pressure and high temperature, is known as ideal gas. That P equal to MRT, you know that P equal to pressure, V is volume, R is gas constant and T is absolute pressure, temperature. Coming to what to be known that water temperature should be 273.16 K or 0.01 degrees Celsius. It's a remember value. And water pressure is about 4.587 mm of Hg or 0.611 kilopascal. Another form of ideal gas equation are followed. Should be noted for air Cp equal to 1.005 kg per kg K and Cp by Cv equal to 1.4. What is ideal gas thermometer? It's independent of material of construction. It's a thermometer in which it is independent in material of construction. It's known as ideal gas, for which 1 Kelvin is defined as 1 by 273.16. For Gibbs-free rule, that's P plus F equal to C plus 2. The basic common formula should be remembered, for which P is phase, F is degree of freedom, C is component. And what is degree of freedom? The number of independent located or fixed in the system or any other system is known as degree of freedom. Now coming to three cases. For case 1, single phase single component, you are having degree of freedom F equal to 2. For 2 phase single component, F equal to 1. And 3 phase single component, that's F equal to 0. You can see that first phase is taken with ice, second phase with ice water, and third phase with ice water and steam. Now, it's a unique state, that is, the unique state is known as the triple point for water, that is 273.16. Now, the two parameters for coming to known under path and point function. Once the variable whose value doesn't depend on path is known as point. It's an example of pressure and temperature, where the variable depends on its past history is known as path. For example, it's heat. Here coming to it, exact differential and inexact differential. The cyclic change of a variable having 0 is known as exact. The cyclic change of variable not equal to 0 you can term as inexact differential. Hope friends you will understand what is the basic of the part in thermal engineering, and I will be continuing with first law of thermodynamics, second law and else. If you like my video, please subscribe. Thank you.